solution. So this is what's in the body at the time you start. So even though you're ingesting water, you're looking at sodium chloride. All right? So the physiologic concentration she will always give you. She will also give you the molecular weight. The other thing she'll give you is how much of each solution you are ingesting. So with all those three values, you should be able to fill out this entire table. One of these will be on your exam. I can't tell you which one. It may not even be anything that she gave you examples of. You could have something like potassium phosphate, all right? Or, oh, there's a bunch of other ones. But you still need to be able to do this. But these three values, what you ingest, the physiologic concentration, and the molecular weight she will give you. So if they're not there, you need to ask me for them. Pretty much they will be. It's the way she sets up her tables. So, first thing you're going to do is look at the concentration in milliosmoles of water. But in reality, what you're looking at is the milliosmoles of sodium chloride. So water is one of the tricky ones. So if you're going to calculate milliosmoles or osmolarity, you would start with the 0.85%, which means it's 0.85 grams per 100 mil. All right, it's not 85 grams, it's 0.85 grams. If you miss the decimal place, you're going to be off by orders of magnitude. All right, can somebody calculate that? I'm not doing the work. You guys are taking the exam. I'm not. How much?
290.5.
How did you get that?
We took the 0.85 per 100 milliliters times the 1,000 milliliters per liter times 1 mole over 58.5 grams times 2 osmoles per mole times 1,000 milliosmoles per osmole.
Crunch the number that you said it was what?
290.598 is what I got in here.
All right. So, if this first calculation is off, it means the rest of your table will be off. So be very careful with this yeah. So go back to your osmolarity calculation. What do you do to calculate osmolarity?
Change it to moles.
Change it to moles. What else?
And then to osmolarity.
What about getting milliliters to liters? You need to memorize that calculation. This is one you really need to memorize. So that whole calculation you should be able to spit out in 1 second. All right? So it's milliliters to liters, okay? Grams to moles, moles to osmoles, osmoles to milliosmoles. So that is what he did to get that number. And if this number is off, that means the rest of your graph or your chart will be off, which means I cannot give you full credit for each one after. You will get no credit for this, but for the other ones, depending on if you did it right, then I can give you, I think each one is half a point, so you get like 1/4 of a point. All right? So make sure that you are very careful, especially with this first calculation. To get total osmoles, it's pretty much volume times concentration. This will not be there on your exam. You need to know that. All right? So essentially, you're multiplying 15 times your milliosmoles per liter. So what is that?
4,358.97.
What'd you say? 4,000?
358.97.
How do you
what are you gonna get on the values there? Like if we're off by points. It's gonna be, not everyone will have a different, cause I accept it,
Yeah.
but depends on whether you round it before you use multiple.
You should essentially, this first decimal place everybody should have the same. It should be the same as what I get.
Right.
The last two, I can give you some leeway on, especially the very last one,
Yeah.
right?
But I
So
know-
at least get it to the first decimal place.
She brings up a good point, because like previously when we were doing these, we wouldn't round prior to that multiplication, but just based upon what Ansfield went over in lecture, it looked like it was rounding, you would round first and then do the multiplication. I think that's what she's getting her number a little off the line.
Mine is, I think it's 0.99.
Personally, I wouldn't round first because it's more accurate if you don't.
Yeah, I mean, the issue in these
But
cases is you have a 12 number long
Yeah.
number to stick in that little box.
So for this one,
Like
like I
I'd
say,
leave that.
that first decimal point, everybody should have, it should be the same.
Yeah, but if she had like 290.5982137, you know, on and on and on, and then she multiplies by 15, she's going to have a greater value than I will, not 12 milliosmoles. Whereas if we round ahead of time, we're going to end up with this number. So I guess I think that was kind of the question: is should we go ahead and round on that concentration
On
of
this one?
milliosmoles first,
Oh.
and then do the?
Yeah, go ahead and keep,
We're
use
not
this
going to fit in
number.
the box
So
otherwise.
round.
So round to this
third
3,
decimal.
to the third decimal, and then multiply by 15. And technically, it's more accurate together, but this way everybody ends up with the same stuff. So, here. What is the physiologic or the initial solution? So this is what's in your body now. And remember that we're using the 0.85. Number 1 and number 3 should be the same. All right? I'm just going to go ahead and copy that.